In this lesson, we are going to build on what we've been working on the last couple days by rewriting an equation that's in standard form, y equals ax squared plus bx plus c, into graphing form, y equals a times the quantity x minus h squared plus k. So yesterday we worked on finding our x-intercepts and averaging them to find the x value, and then of course once you find x, substituting it in and finding y. And then that gave us our h and k value. Then we proceeded on to working with completing the square, so using that strategy. So what we're going to look at today is which of these methods works better in different situations, because there are going to be some limitations to each of them along the way. So to begin with, what I want you to do is, so problem 242, I want you to compare the two methods of changing a quadratic from standard form into graphing form. So the first way we're going to do this, so for part A, you're going to write the equation of that parabola, y equals x squared minus 2x minus 15, using both forms. So you are going to do it twice. So one time you're going to average your x-intercepts and find the vertex that way, and then the other one you are going to complete the square. Additionally, with these methods, you're going to be finding the x-intercept, the y-intercept, and vertex of the parabola, and then you're going to sketch it. So go ahead and pause this and do both of those methods. So when we find the two x-intercepts, we have 5 and negative 3. So we're going to average them, so add them together, divide by 2. So therefore the x value of your vertex, so 5 plus negative 3 is 2, 2 divided by 2 is 1. So the x value of vertex is 1. Take 1, plug it back in for your x values, and your y value ends up being negative 16. And then based on that, we can write our equation in graphing form. Our a value is the leading coefficient, which is 1. Therefore, it's x minus 1 squared minus 16. Okay, then we will complete the square. So as I set up my box and I was completing the square, I got 1, but it's supposed to be negative 15. Therefore, we have to subtract out that 16. So y equals the quantity of x minus 1 squared minus 16. So same equation, just two different methods. And then I asked you to graph it. And I also want you to find your x-intercepts, y-intercept, and the vertex. So we found our vertex, we found our x-intercepts, so we knew both of those from averaging our x-intercepts. Finding my y-intercept, remember, how do I find a y-intercept? Value of x, value of y when x is 0. So therefore my y-intercept is the point 0, negative 15. And then I'm going to sketch my graph. So as I plotted those points, I have my 2x intercepts. I counted my y-axis by 2's. So therefore my y-intercept is at negative 15. My vertex is at 1, negative 16, which means I have this symmetry piece right here at 2, negative 15. And then I draw my parabola. Bear with me, this isn't going to look good. Sorry about that, hard to do on my little screen. Okay, so we've got all of our information based on doing both of these. So the next part, I want you to write the next problem. For part B, y equals x squared plus 8x plus 10 in graphing form. Additionally, I want you to find the intercepts, all the intercepts, the vertex, sketch the graph, and then I'm wondering, do both strategies work for this? So would you be able to do both completing the square and averaging the x-intercepts? But again, I want all of that information, so use whatever method seems to make sense for you. So I did my quadratic formula. I got my two x-intercepts. I did simplify the square to 24. Which is the square root of 4 times the square root of 6, which is 2 square roots of 6. And therefore, I could divide that entire numerator by 2. So I get negative 4 plus and minus square root of 6. So finding the x-intercepts, I could then average them, add them together, divide by 2, get the x value of your vertex, and then plug that in and get your y value. If you instead decided to complete the square, that works as well. So completing the square, x squared, 4x, 4x, which is x, 4, 4. That brings in a 16, but it's supposed to be 10, so you subtract out that 6. So y equals x minus 4 squared minus 6. So based on that now, I know my vertex. Run out of space here. So I have my vertex at 4, negative 6. I have my x-intercepts at negative 4, negative 6. And then I can find my y-intercept. Standard form is really nice for that. So my y-intercept is 0, 10. And then we can go ahead and plot that. Keeping in mind, this number here, -4 plus and minus the square root of 6, isn't super helpful when I'm trying to graph my x-intercepts, but it does help me do other things with them. But these are my exact values. I can write them as a coordinate point, -4 plus the square root of 6, 0, and -4 minus the square root of 6, 0. So I just have plus and minus. Okay, so plot those points. Again, those are decimals. If I really wanted them, I can punch them into my calculator. I could also use the fact that my stretch factor is 1, and I know for my vertex it goes up 1, over 1, up 1, over 2, up 4, and I get my parabola. So, could I use both strategies? Sure. Which one was maybe easier? Only because we had this square root that was in here. Still doable, but completing the square was probably a little bit easier on this problem. Okay, now for C. Take a moment and determine if both strategies work to graph this one, y equals x squared plus 2x plus 4. As you start to try to figure out your x-intercepts for this one, there are none. There are no x-intercepts for this because the vertex is above your x-axis. So for this one, I can still use the process, but I'm not going to find any x-intercepts. So therefore, when I complete the square, I get x, 1, 1, which brings in a 1. It's supposed to be 4, so add 3. So y equals x plus 1 squared plus 3. So you know your vertex is -1, positive 3. Be careful with that negativity. And we know it opens which direction? Up. So therefore, here's my point. Stretch factor is 1, so over 1, up 1, over 2, up 4. And draw the parabola to the best of your ability. So could you use both strategies? Yes, but there are no real x-intercepts. So there's that piece of it as well. So what I want you to think about now is, when does averaging the x-intercepts work best? When does completing the square work best? And think about which method was most efficient and why. So write down a few things and then I'll talk to you about it. So in a problem like the very first one, where we had nice integer values, pretty fast to find your x-intercepts, average them, you get your vertex. It instantly tells you your vertex. And I've also found my x-intercepts. So when I had to find my x-intercepts anyways, I might as well average my x-intercepts. Okay. Whereas in a problem such as this one, where maybe I'm not going to graph my x-intercepts, now granted, I asked you to find them, so you find them when you do that process. It's part of the problem. Otherwise, you've got to find your x-intercepts another way, like with this equation, with your graphing form equation. But no matter what, you're going to have to find those x-intercepts. So this one is not quite as nice to write into graphing form, but still helpful if I want my x-intercepts. Here, there's no x-intercepts, so why not just jump to completing the square? So for these two problems, use either strategy that you want, just to give yourself the practice of either averaging the x-intercepts or completing the square. So when you do that, your first equation in graphing form, and the second equation, this one had some decimals for your vertex, but no big deal. This one, completing the square, might be a little bit more challenging because it was a 5 in the middle, so that's going to lend to those decimals. So if you get a problem like this and you're like, oh, my method doesn't seem to be working, so if you really like completing the square, this might be one of those problems where you instead jump to averaging your x-intercepts. Completely your choice, though. Okay, so when we have something in graphing form, we want to be able to look at being able to make that quick sketch, but also being able to find those key features. So when I give you this equation here for part A, I want to know what is the vertex, what is the y-intercept. So hopefully you can very quickly do this. So go ahead, pause it, calculate that. So from your vertex, or from your graphing form, you can instantly find your vertex. So 3, -25. If I want to find my y-intercept, when it's in graphing form, it's not as easy. If I want my y-intercept, it's the value of y when x is 0. So I physically have to substitute 0 in place of x. So I'm explaining that right now. So into my equation, I get y equals, so 0 minus 3, so that's -3 squared minus 25. So -3 squared is 9, Minus 25 is negative 16. Therefore, it's 0, negative 16. When it's in standard form, you instantly see your y-intercept. When you plug 0 in, it's just your c value. But when it's in standard form, you do not see your y-intercept. You have to do the math to get there. Okay, then, same problem. Now again, when it's in graphing form, I want to find the x-intercepts. Because just like in these problems back here, if I completed the square to get it into graphing form, I didn't have my x-intercept. So now I have to solve for my x-intercept still because I'm asking for those intercepts. So you have to have a method algebraically to find those x-intercepts. So to find your x-intercepts, again, the x-intercepts are the value of x when y is 0. So I substitute 0 in. Now we have to be able to algebraically solve this. So pause it for a moment, go ahead and solve. One method you could use is you could expand this whole thing. X minus 3 times x minus 3 and get x squared minus 6x plus 9 and then minus 25. Or, easier in my opinion, undo those operations. Add the 25 to the other side. Got to get rid of that square, so square root. What do you get when you square root both sides? Good, positive and negative 5. So then you have two equations. I'm just going to separate these out so you can see them. X minus 3 equals 5, and x minus 3 equals negative 5. So add the 3, add the 3. So you get your two different x-intercepts. So 8, 0, and negative 2, 0. Again, sometimes it's easier just to find your x-intercepts from standard form, but sometimes we don't have standard form. Okay, so that's part of why when we were going through these problems, it might make sense for you to average your x-intercepts instead because you have to find those x-intercepts at some point. So in standard form, you have that method. When it's in standard form, it takes a little bit more time to find those. And then the last part, so I want to find, in this new equation, I want to find the vertex, y-intercept, and x-intercepts of this graphing form. So take a moment, go ahead and find the vertex, x-intercept, y-intercept. Okay, so in terms of sketching this graph, I have my vertex, I have my y-intercept. My x-intercepts aren't really nice values, but I could find my decimal approximations on my calculator. So negative 5 plus 2 square roots of 2, negative 5 minus 2 square roots of 2. So that gives me each of my values on each side. I can also find my symmetry piece because I know over the line x equals 5, I have the symmetry. Over here at negative 10, 17. And then I can graph it. Again, I know my stretch factor is 1, so I could go from my vertex 1 over 1 up, 2 over 4 up. Keep in mind, make sure your parabolas are U-shaped. I've been seeing a few V's along the way as well. Okay, the very last problem then. So what we want to look at is, what if my equation, how can I write my equation every single time? So if I have a standard form equation, y equals ax squared plus bx plus c. So I want to find this. So I'm starting with this equation. I want to find the x-intercepts. Again, we're looking at this from a very general form. We're not putting numbers in for a, b, or c. So if I just give you letters for the coefficients, can I find my x-intercepts by factoring? No. How about completing the square? It's doable, but incredibly hard because we have a leading coefficient of a. If you remember, our downfall to completing the square is if there is that leading coefficient. So you do not necessarily want to complete the square if there's that leading coefficient because you typically will get it wrong. Not always, but you just have to be super careful. So therefore, we are going to go ahead and find our x-intercepts here. And we are going to look at averaging our x-intercepts. So in this process, I solve for my x-intercepts. I know this is kind of weird, but we're going to solve. So x equals the opposite of b plus and minus the square root of b squared minus 4ac all over 2 times a. So it's the quadratic formula because the coefficient of x squared is your a, coefficient of x is b, and the constant term is c. So therefore, if I want my x-intercepts, I just found them. The one is negative b plus the square root of b squared minus 4ac all over 2a. And the other one is the opposite of b, minus the square root of b squared minus 4ac all over 2a, comma 0. So those are my two x-intercepts. So now, again, this is generalizing this. If I have my two x-intercepts, how can you use your x-intercepts to find that line of symmetry? Which again, remember, your line of symmetry is what goes through the vertex. It's the x value of your vertex. So how do I find my line of symmetry if I have these two x-intercepts? We average them. So take a moment and average these two fractions. Okay, I just moved them down here because I didn't have enough space. So therefore, to average these two x-intercepts, I'm going to add them together and divide by 2. Remembering that dividing by 2 is the same thing as multiplying by 1/2. So therefore, when I add them together, they got to have common denominators. They do. So therefore, my numerator says the opposite of b plus the square root of b squared minus 4ac plus a negative b minus the square root of b squared minus 4ac. And that's all over 2a. So that gives me 1/2. And then in the top, I have a positive and I have a negative, just like we did when we have numbers. So when I add a number and its opposite, I get 0. So I get negative 2b, because negative b plus negative b is negative 2b over 2a. You see where this is going? So it's the opposite of b over 2a. What did we just find? The x-intercept, average, which is the x value of your vertex. And once you know your x value of your vertex, how do you find the y value of your vertex? Plug it back into your equation, and it spits out the y. So what is the vertex of this graph? The x value is the opposite of b over 2a. And then again, once you know this, so say it's 5, plug 5 back into the original equation for x, and then you'll get your y. If you really wanted to plug in the opposite of b over 2a into the original equation, you can. So for your x value, you can put that in for each of the x's. It's kind of goofy. It's pretty messy. It just ends up being c minus b squared over 4a. Not something super helpful that you're going to remember, but this piece right here is crazy helpful. And you actually see it in your quadratic formula, because this part here, the plus and minus, is what goes away when you're averaging them, because you're adding them together and dividing by 2. So therefore, when you want to find the vertex of a parabola, you can use this premise. Why? Because we averaged the general case. So now what I want you to do is I want you to go back to this very first problem, y equals x squared minus 2x minus 5, and use that shortcut. Find the x value of your vertex. So your vertex is the opposite of b. The x value of your vertex is the opposite of b, so that's positive 2 over 2 times the a value, which is 1. Therefore, the x value of your vertex is 1, which is what we calculated here. And that all comes because we averaged our x-intercepts. So now, when you are putting an equation from standard form into graphing form, you have 3 methods. Technically, it's 2 methods, but 3 methods in essence. You can average the x-intercepts, you can complete the square, or you can use this premise of the opposite of b over 2a, which again comes from averaging the x-intercepts. And once you do that, you can get it into graphing form. Keep in mind, along the way, you are still going to be finding a lot of different things. So different methods are going to lend themselves differently. So just making sure that you're comfortable with what cases are helpful.